Good morning, everyone. This is Bharti Kalyani from ECC. Today, I am going to explain about basic conversations of number systems. First, we will see about types of number system. First one is decimal. It is also called as base 10. Here, we will only see the numbers between 0 to 9 and the numbers may be repeated. And the second one is binary. Here the numbers used are only 0 and 1. They are also called as on and off states. These are mainly used in computers or systems. Octal is called as base 8. Here we use only the numbers between 0 and 7 in this number system. Hexadecimal. In this number system, we only use the numbers between 0 to 9 and the remaining numbers like 10, 11, 12, 13, 14, 15 are represented with alphabetical letters like A, B, C, D, E, and F. Now, first we'll see about decimal to binary conversion. Converting the decimal number to binary, we have four steps. First one is dividing the given decimal number by 2. We need to divide the number and need to write the remainder beside it. The reminders must be 0 or 1. It is compulsory or it is the system. Next, it need to be repeated if the coefficient is 0 or 1. Mainly, it need to be 0. In some cases, they will return as 1. Now, we need to write the numbers 0 and 1 from bottom of the division to the top of the division. Then that is called the binary number, which we get from the decimal number given. Second, we will see about decimal to octal conversion. First is we need to divide the number by 8. Next, we need to write the reminders from 0 to 7 and the reminders should not be above or equals to 8. It need to be below 8 and repeat the division with 8 until we get coefficient 0. And we need to write the readings from bottom to top. Here, an example 315 base 10 means 315 decimal number. We need to convert the 315 decimal number to octal number. We need to divide that 315 with 8. We'll get remainder 3 and coefficient 39. We need to divide the 39 with 8. The coefficient is 7 and the remainder is 4. We cannot divide by 8, so we can leave the 4 like that. If we want, we can go here, or if not, you can leave it. Then 473 are the numbers. We need to write from bottom to top. So 473 base 8 is the octal number of 315 decimal number. Second one is decimal to hexadecimal conversion. Here we convert decimal number to hexadecimal. We need to divide the number with 16 and the reminders are written 0 to 9 if they are between 0 and 9. If they are more, we need to write with the represent alphabet given to the numbers like 10, 11, 12, 13, 14 and 15. We need to repeat the same division up to we get the coefficient 0. We need to write the sorry. We need to write the order from bottom to top. Here we'll see an example. Here 1457 is the decimal number. We need to divide it with 16. We'll get remainder 1. Next we need to divide with 91 with 16. We'll get remainder 11 and 5. Here 11 is represented with an alphabetical letter B. So the hexadecimal number for 1457 is 5B1. Next, we will see about decimal to binary conversion. To convert, we need here in the before decimal to binary, we have divided the given decimal number with the 2. Here we need to multiply the binary number with 2 with the respective powers associated for that position. For example, first place is 2 power 0, second is 2 power 1, third is 2 power 2, fourth is 2 power 3, and fifth is 2 power 4. Here the position is n, then the power associated for it is n power n, sorry, 2 power n minus 1. So here 10110 1 into 2 power 4 plus 0 into 2 power 3 plus 1 into 2 power 2 plus 1 into 2 power 1 plus 0 into 2 power 0. The numbers we get is 16 plus 0 plus 4 plus 2 plus 0. That is total of 22. Here the decimal number we get for this binary number is 22. Now we see from octal to decimal conversion. Like before, I said it is like this. If I took a number 200, no, 206.104 base 8, we need to multiply the, here it is a base 8. So in before case here binary means it is base 2. So there we have taken 2 power. Here it is base 8. So we need to take 8 powers. It is 0. It is first position and the 8 power 0 means 8 power n minus 1. Here n is the position they represent. As we know, it is 6 into 8 power 0 plus 0 into 8 power 1 plus 2 into 8 power 2. Now we will see after the decimal point. It is 1 into. If it is 0 position, we know that e minus 1 power. So it is 0 minus 1. So 8 power minus 1, 8 power minus 2, 8 power minus 3. So like that, here the number is 2 into 8 square plus 6 into 8 power 0 plus 1 by 8 plus 4 by 8 cube. So the answer is fraction 17 by 128 base 10. It is the decimal number for 206.104 base 8. Second, we will see about hexadecimal to decimal conversion. Here, like before, I said it need to be on the position of the number. Suppose if they have given 5b1, here b represents 11. So 5 into 16, 5 into 16 square plus 8 into 16 power 1. Sorry, 11 into 16 power 1 plus 1 into 16 power 0, which is equals to 1457. Likewise, we do conversations to get the accurate value how the computers or systems work in number systems. And here the number systems are created in computers like this. Thank you very much for your valuable time.